Let's look at a similar example. What is the arc length of the arc subtended by the angle 165 degrees for a circle with radius 8 inches? So we're asked for something with arc length about arcs subtended by angles, so we need to remember what that is. So for a circle with radius r, the arc length of the arc subtended by the angle theta is r times theta. And further, this theta, as we stated in the previous part, theta has to be in radians. So we need to keep that in mind. And since we're not in radians, we need to remember how to translate between the two. So the easiest equivalence is that 180 degrees is equal to pi. So that way we can convert from degrees to radians, so we can actually do this computation. So let's go to the board. So we're being asked for arc length. We know that we have a radius of 8 inches. We have our angle, which is equal to 165 degrees. So what do we want? We want the arc length, which we know is equal to r times theta when this is in radians. So let's translate this theta from degrees into radians. So how do we do that? Just like we did in a previous video, we talked about how to translate from degrees to radians. And really all we do is we remember that this equivalence, we have 180 degrees equals pi. So therefore, we have two equalities. We have the number 1 is equal to 180 degrees divided by pi. And also that 1 is equal to pi over 180 degrees. So why do I write it this way? Because if we multiply by 1, we don't change anything. We know that we multiply 2 by as many ones as we want, we're always going to get 2. So this is essentially what we want to do. To translate this into a different unit, we just want to multiply by 1. So how do we translate to radians? So what's the difference between these two? It's where are the units. So we have degrees in the bottom here, and here we have the degrees in the top. So if we think about this, we're going to multiply by 1. We could think of this as 165 degrees over 1. So if we're multiplying by a fraction, we want the units to cancel. We want to have degrees in the denominator. So therefore, we want to use this version of 1. So let's multiply 165 degrees by 1, which is pi over 180 degrees. So if we grab these colors, we're going to multiply together. We don't change any units here, and we also don't change any units here. Radians are kind of thought of as unitless. So this top part is just degrees, and so is this bottom, so we kind of get rid of both of those, which is very nice. So all in all, if we want to write this theta angle, which is written poorly, theta is going to be equal to 165 times pi all over 180. So this is an actual radian measure, but we can definitely simplify this a lot. So what is this? This is divisible by 5. So it's 5 times what? Well, let's just do old-fashioned division. So 165 divided by 5. Well, 5 goes into 16 3 times. And we multiply that down, we get 15, so we have 1 left. Bring down the 5, and 5 goes into 15 3 times, and that's exact. So therefore, 165 is equal to 5 times 33. If we do the same thing for 180, then this is just going to be 5 times what? By whatever this should be. So we divide 180 by 5. Again, 5 goes into 18 3 times with a remainder of 3. And 5 goes into 30 6 times. So therefore, 180 is equal to 5 times 36. So let's write this in a little more coherent manner. So this angle is equal to 5 times 33, and let's just break up 33 as much as possible. 33 is just 3 times 11, and then we have a pi left as well. So this is all the 165. And here is our 180, so we have 5 times this, times 36, but we have a 3 up here, so we would like to pull out a 3 if possible. So 36 is just 3 times 12. And now if we simplify this fraction, since this is all multiplication up top and all multiplication in the bottom, we can factor out the 5 and the 3's, and then it's just 5 over 5 and 3 over 3, which is 1. So all we're left with is 11 pi over 12. So great. Our answer is not this. Remember, what we were doing was we were trying to find what the arc length was, and we needed to make sure our angle was in radians first. So now we have our angle actually in radians. So if we want to compute the arc length, it's equal to the radius, which is 8 inches, times this number right here, 11 pi over 12 inches. And we can simplify this a little bit. We can think of this 8 as 8 over 1. So we're multiplying and we multiply across. And likewise, since this is just multiplication, we can cancel terms around. So this 12 has a 4, that's a factor of it, as well as the 8. And what's left after we get rid of the 4 here? Well, we just have a 3 in the bottom. And if we get the 4 out here, we have a 2 left. So therefore, this fraction simplifies to 2 times 11 times pi all over 3 inches. And finally, our arc length for the angle, for the arc subtended by the angle 165 degrees for a circle with radius 8 inches is exactly 22 pi over 3 inches.